These notes are over chapter 4.3, temperature and heat. Okay, so temperature is just the average kinetic energy of the matter or particles within an object, okay, or a substance. So remember, kinetic energy is the energy of moving objects, and so all matter is in constant motion, okay? So even if we look at something like a solid, you would say, okay, well, those particles aren't moving. They're just moving very slightly. They're vibrating in place, okay, but they're always moving. And so temperature just measures what the average movement of the particles within a substance is. Okay, the SI units for temperature is K, Kelvin, but a lot of times in science we do use degrees Celsius, okay? Here in America we do use degrees Fahrenheit quite a bit, but as far as scientific measurement, we either use Kelvin or degrees Celsius. Okay, when particles are stopped, which is a theoretical number, it would be a 0 Kelvin. This is absolute zero, and we'll kind of talk more about that a little bit later. So the faster the particles are moving, the higher the temperature. Okay, so if the matter has high kinetic energy, meaning they're moving around super, super fast, okay, they're going to have a higher temperature than a particle that's just vibrating in place. It's going to feel cooler. Okay, so temperature just measures the motion of the particles. And just as a reminder, here is the conversions for the different units of measuring temperature. So Kelvin, degrees Celsius, and Fahrenheit. Okay, so heat is different than temperature. Heat is actually the transfer of thermal energy, and we're going to define what thermal energy is, from one object to another. Okay, so if you think about the sun, the temperature of the sun is much different than the heat that we feel from the sun. Okay, so the temperature of the sun is very, very, very high. Okay, but the heat that we feel from the sun is going to be a lot less. Okay, and that's because it's the transfer of the thermal energy. Okay, so it's due to temperature differences. So if you have two objects that are at the same temperature and they were to be touching, they are not going to experience heat or the transfer of thermal energy because they're both the same. Okay, but if we have an object that's cold and an object that's hot, we will get heat transfer between the objects. Okay, so heat flows naturally from high to low. Okay, so you could think of it as hot to cold. Okay, but an important thing to note is that cold is just a lack of heat. So a lot of times when I talk about heat transfer and the transfer of thermal energy, I talk about heat vampires. I personally am a heat vampire. My hands are always really, really cold. So whenever I go to like shake someone's hand or give them a high five or anything like that, my hand feels cold to them, but as I hold their hand, okay, my hand is warming up, okay? So I'm pulling the heat from them. So the energy that was in the particles of their hands is transferring to the particles on my hand, okay? So their hand feels cold because I'm pulling away their heat, okay? So the feeling of cold is just the lack of heat. So when we touch something cold, what's happening is it's actually just stealing our heat. It's not that the object is pushing coldness into our hand. So thermal energy is just the total potential and kinetic energy of all particles in the object. So it depends on three things: the mass of the object, the temperature, and the phase of the object. So if it's a solid, a liquid, or a gas. Okay, so for example, if we had a hot cup of tea versus a pitcher of hot tea, the masses are going to be different. Because the pitcher has more mass, it actually has more potential and kinetic energy. It has more thermal energy. Okay, so if you have ever experienced this, if you have a large pitcher of something that you're trying to cool off, if you put it into smaller containers, it'll get cooler faster. Okay, and that's just because the thermal energy is less when you have less mass. And then also if we have a cup of hot tea versus a cup of cold tea. Okay, so the temperatures are different. This is going to be the kinetic energy being different. So the cup of hot tea is going to have high kinetic energy, thus it's going to have a higher thermal energy compared to the cold tea, which is going to have a lower kinetic energy. The particles aren't going to be moving as fast. Okay, and so here we have a diagram of kind of heat flow. And so remember, heat is the transfer of thermal energy. And so we have two objects. We have an object that is cooler or has lower temperature. Okay, so the particles are not moving as quickly, so you'll see the arrows are less than the warmer object A. Okay, that has a particles that are moving around more rapidly. It has a higher temperature. When we push these two objects together, what happens is that the high energy of these particles will start to bump into the slower particles here, making them speed up, okay, until they reach an equilibrium. So it basically averages out the temperature until they're both the same temperature, and then there's going to be no longer any flow of heat between the objects because they're both the same temperature.